Use a lot of the industry standard packages, SolidWorks for 3D modeling and design and engineering and things like that, for blueprint creation, that sort of thing. And Esprit is the CAM system that we use, is what that's called, computer-aided manufacturing or computer-aided machining, depending on whose namesake you follow. So what that allows us to do is, drawing a 3D shape, that's well and good. We can use all the tools and things like that inside to find interferences, to find stack-up tolerance types issues. It's as far as you take it. So the more that you apply to that, just like any other machining process, the more reward you will get. So seen here is the basic slide that we offer. This is no frills, basically 66-degree angled, like forward angled serrations is something that was very big, very asked for. And then it's just a clean product. So when it comes down to it, the actual manufacture of a slide, there's slots, there's flats, drilled holes, etc. And it just comes down to the little things, like why we chose to put the bevel on there the way we did and things like that. So all those things have a reason. So after that's done, then we'll bring that over into our machining software, which I can show a little bit of this that's not proprietary. It works similar to any other big name machining software. So if you use like a Mastercam or a Delcam or something like that, there's a lot of great softwares out there. We've chosen Esprit. Esprit is the most versatile for all the equipment that we use. It allows us to post guaranteed safe code on all of our different machine types. So we have everything from a 4-axis horizontal mill to a 9-axis twin turret, twin spindle lathe that runs 2 programs simultaneously. So checking all your P's and Q's and things like that becomes very serious whenever you have the potential to make or break a $450,000 piece of equipment.
So layman's terms, for people to understand why the axes are the way they are, like why is 4 better than 1 or 2 better than 9, or?
It's all about access. So let me grab a part here to show. The old school way to do things would be with like a 3-axis mill or something like that, where you hold the part in one orientation and you do as much work as you can. Then you flip it and you do another orientation, do as much as you can. So on this part, you can get away with that on a 3-axis. On this part, you can't make this on a 3-axis machine. The reason they call it 3-axis is, okay, you have Z, X, and Y. So if you have a multiple axis machine, it also gives you the ability to rotate the part. Every time you add an axis, you add an extra ability to turn the part, to access the part from a different orientation. So what that means for us is precision. So if I use a multi-axis machine to make a part like this, I can clamp it, I can machine everything that's happening out here on the breech face, and I can control my headspace to what's going on back here where the fire control group is going in, where the firing pin, the bolt shroud, and all that stuff happens. So all of that stuff is going to be able to be held within the tolerance of our manufacturing centers. So instead of having to do the long legwork method of move it here and then move it down to this operation, and 7 machines later and 7 operations later, you could have a theoretical error stack up that makes the product not work. So by investing in the high-tech machines and the multi-axis, well, a 5-axis machine that holds it in this orientation, not only can the machine zigzag all over it and drill all the holes and do what you need, but it can also orient it this way and handle all this work, and then it can orient it this way and handle all that work.
Gotcha.
So what that does is that's how you're competitive in modern industry. So 10, 15 years ago, a 3-axis mill was adequate. It isn't anymore. It's not competitive. A 3-axis mill is a good secondary operation type machine where I need to mill off a backside or put a couple of holes in. They still have their place in industry, but if you want to be efficient on this level and provide the quality that we have at the volume, you need to combine operations for your process fidelity. You just have to. So that's where axis comes into play. So with the increase of axes is also the increase of program complications. So that's where it's sort of, as the axes go up, the skill in industry has to go up as well in the training. So yeah, I think that covers that.
Cool. So I mean, we've kind of gotten a little glimpse as to how everything's kind of put into thought and some process, and then obviously putting the coding into your machines and everything. So let's go on the floor.
Sure, let's do it.